Thank you all very much, and thanks for doing this and inviting me, and I am so impressed with all the work that you've all done. It's really great. And I wasn't the environmental specialist for the City of Portland. I was one of the environmental specialists with the Bureau of Environmental Services. I was the first landscape architect hired by, at that time, a sewer bureau, which is now likes to refer to itself more as an environmental watershed bureau, but it still handles sanitary sewage, handles stormwater, and handles addressing federal and state regulations. I got my start with the bureau some of the early work was in the 1990, 1989, and I was actually assigned to work on the city's response to the NPDES permit for the MS4, so the separated stormwater system. There were about 50 engineers at the Bureau at that time, and they sort of dumped it on the new guy that was the landscape architect, so let him, the environmental specialist. So you could be a landscape architect or other disciplines to get that kind of position at the Bureau at that time. Anyway, I loved it. I was reading it, and it was like, wow, this all makes so much sense. Somebody really had an eye for planning, zoning, how to take care of things from maintenance and everything else. It was like so much of what we are all trying to do was in the guidance document that came out from EPA about what it all meant, including planting trees. And so that was kind of something that really caught my attention. That was in the draft. They took that reference out in the final draft guidance document that EPA put out. Tom might have known about that. Anyway, but that's not what I'm going to talk about. I want to talk about cost, because in working on these issues, I worked for the City of Portland for 25 years, I worked for the City of Orlando, Florida for 9 years, and I was in private practice for 7 years in between. And now I'm in private practice, although I am on the board of directors of the Urban Green Spaces Institute, which is stationed or headquartered in Portland. Well, let me get going here. So, someone has already mentioned Robert Marassi, and he did pass away, but he did some really good work. And he and I put together a chapter in a book back in 2000, and this was his quote. And I thought I just ran across it, and I thought about how, what am I looking up there for down here? Anyway, so you can see how he references artful place. All have an artful place with people. And people in this conference have already said that. Water and place and people. A number of people have talked about that. But this other, it's not really a quote. In a sense it is. When I was working in Orlando, and we used to design the city parking lots. So we put a lot of attention into landscaping parking lots in the city of Orlando back in the 70s. I don't know what they do now. So the chief engineer was being required by the state to infiltrate the water. So his basic idea was, well, let's put it in the landscape. So I was assigned to as the project manager of this project, and he told me and my boss in a special meeting to tell us, you're going to have to handle this water that's going into the landscape. And we were just like, whoa, really? Okay, that sounds good to us. But the point of this is that at that time, it made so much sense, and it still makes so much sense. Put the water in the landscape. And if you don't have landscape, find a way to create landscape, or find a way to make everything more pervious. So anyway, all the things that people have talked today. So along those lines, then something that was serendipitous that occurred. So we had this large project, and I'm now working for the City of Portland, and I'm reviewing plans. And so this project came in, and I thought about the project from 1978 that I worked on in Orlando. And I saw all these landscape areas. And in the City of Portland then and today, we have landscape requirements for parking lots and actually all development. So you have to do a certain amount of landscaping. And so they had these linear landscapes, median strips, and they were all raised. So the landscape was raised, the pavement was concave, and it had inlets all over the place. Anyway, so I suggested, and OMSI is the Oregon Museum of Science and Industry, a nonprofit, really cool place, kids love it and everything. and adults. And at any rate, so I suggested to them, what would they think about making everything the opposite? So crown the pavement or slope it, and then depress the landscape. So OMSI was like, hey, that sounds really cool. This is, because they're really into cool science kind of stuff and everything. So this happened, and Morassi happened to be the landscape architect on this job, and it turned out that he was the landscape architect on a number of other jobs. I actually worked for Bob back in 1985 and 1986. And anyway, so this happened. And so what does this have to do with cost? So these are just some shots of what it looks like. Originally, we didn't think that it was going to infiltrate, so they were actually signs that were created that said working wetlands. Well, it turned out that after about 6 months, the working wetlands started to infiltrate quite readily. And so I think a lot of us, at least in our region, have this concept that there's something about this idea of the underdrains and design in the east that we either just don't know about, or there's something that maybe we all just could learn more from each other. Anyway, so these are just some shots of the parking lot. So here, the gradient was changed in terms of the design. It was never built the first way, the conventional way, but then the water drains into the landscape, and it's kind of like a lot of projects that are out there. Now, what was unique about this is that OMSI already had a design-build contract. So, and the designers on this was ZGF and KPFF engineers, and then Morassi's office. So, when I made the suggestion, then they had to, when their client said, yes, I want to do what this guy from the city's suggesting we do, so they had to redesign it. Well, they all embraced it, and it was like, yeah, this sounds really cool. So what they did have, though, is that they already had all of their construction costs detailed for the project in the conventional design. So when they switched to this design, and they did have to pay more for design work to switch the design, but after it was all said and done, and the project was constructed, and this is in 1992 when it was finished, the construction dollars that OMSI realized from that detailed accounting was $78,000 cheaper than the conventional design. This, to me, there's a very subtle, interesting issue here. If the conventional design is actually more expensive than this design using a landscape approach, then how is it that all the conventional thinkers can say that water quality and stormwater management is going to cost us more money? The conventional design is actually costing more money. So there's a new way to design that's better than the conventional. At least this project suggests that, or even proves it. Now, the other thing that happens in Portland is we do have a stormwater fee or utility, and so you get a discount. Oops, that doesn't change it. And so OMSI, from what they would normally pay for 9 acres of parking, would be $46,000 a year is what we charge, or the city charges, and they get a discount of 35%. So they save $16,000 on this parking lot design annually, which is very helpful for taking care of the landscape. Now, they were always going to have a landscape because we require you to have a landscape if you're in the city of Portland and you're going to develop a certain amount of landscaping anyway. Now, the other thing about this that's pretty interesting is for a long time we thought this was an anomaly, that it was just this project that worked out this way. After this, and as I'm working on many of these issues with stormwater, and contractors, especially developers, are saying, these regulations are going to kill us. We're going to have to spend so much money for stormwater and everything else. I contend that the people that cause the most cost for stormwater management are the people who have the least skill in being able to design facilities. Anyway, so then as years have gone by, now we have a combined sewer system. This is our city here. This is separated sewer. Anyway, we have this problem. Besides, in the Clean Water Act, we have all these issues of point source and sanitary sewage, things like that. And we also have a requirement that cities are not allowed to allow basements to flood from combined sewage. And if that's happening, we have to fix it. So we've got hundreds of millions of dollars worth of work to do. And in the course of doing this, and so the money in this. So this new development, now we're talking about retrofitting. And Philadelphia is really, I'm so proud of Philadelphia. I'm so happy about Philadelphia. I mean, it's just like, anyway, so this is about 2,000 acres of developed land. We've got to get the water off the system, which is what Tom's trying to do with his group. And so this is what it looks like from a very area view. It's, there's an old extinct volcano up here that's a park, and then it's residential, commercial coming down to here. So within this area, we need to get a lot of water off the system and prevent these basements from flooding. So in 2000 and, well, it doesn't show the year here, somewhere around early 2000s, it was a gray design or conventional design for upgrading the pipes. It was $144 million. And then, and that was too expensive to do, so it got put on the shelf and put on the shelf. And then in 2006, the Bureau decided, well, let's rethink this, and let's apply green. So green streets, as you've seen, and various other, retrofit, everything's retrofitting, right? So we have to do this, $144 million. They applied $11 million worth of green approaches, primarily parking lot retrofits and green streets. And then they recalculated the flows. The modelers redid the flows, the engineering modelers, and they found that this got enough water off that they only needed $75 million for the gray. So the bottom line is the Bureau was going to save $58 million by going green for retrofitting. And we have to do this. I mean, we could keep putting it off and various other things, but eventually we have to do it. So that's good news. Now the bad news is you can't use capital improvement money for maintenance. And landscaping is a little bit more expensive to maintain than a bunch of pipes underground, until the pipes underground start to fail. But anyway, so now just to show you some of the early work, this is one of Marassi's projects. This is the Environmental Services Lab. This was a very fun and interesting way to manage the stormwater, putting it into the landscape and just letting it shoot right off the roof. In most places, you're not allowed to do that. In terms of letting it just do that, so you got to get special permission, but that was kind of nice. This is another project that we did, and this is called Headwaters, and it's a retrofit of putting a rain garden in and a creek, and then this is a retrofit of a commercial area that's over here to the left, and it drains into this area and then goes to the rain garden. The reason this channel was created was to get the water over the top of where the creek culvert comes underneath the road right here. And I just switched topics on you. I don't know why, just went in there like that, and that's one rain garden cell draining to the next rain garden cell. And then this is more examples of this idea of putting water into the landscape. So this is one of those redevelopments, so it's not new development, but it's a redevelopment of an existing building. And I like this. I think, look at this repetition, and it's so simple and so easy. They just said, well, we've got to have the landscape. That's how we're doing the landscape. And then they just put the curb cuts in, and that's where the water goes. And this is what it looks like a couple years later. This is Boise, Idaho. This whole parking lot drains into this landscape. I was there for a conference, and I just took a walk, and I just saw this. I thought, now why am I here talking about stormwater when these guys already get it? Well, there's a lot of stuff out there that's actually good stormwater management that nobody really knows how it got there or who designed it. This is a project in 1986. This is when I was working for Marassi Associates, and we were at this school. And I just took a walk, and Bob was doing some more work with the architects. And I saw this swale, and I thought, isn't this interesting? And that's stormwater management. That's how it doesn't look very good, but it's a pretty simple, straight design. It's got a little bit of vegetation in. But anyway, this is stormwater management in California. This is Charlie Brown's restaurant in San Gabriel. If you ever go there and it's raining, this is how they manage their stormwater. This was my mom's condo, and when it rained that day, I finally found out that this little planter there was where the downspout drained and it just dropped right off the roof. So from big to small and everywhere in between. And now I want to tell you a little bit about the work in Malmo, Sweden, and Peter Starr and this group of people here. Some of you might recognize Bruce Ferguson. This is Peter Starr. Unfortunately, he passed away a few years ago, But he and a lot of people in Scandinavia really got this idea, and their point was, as it's represented in his book, I put this up because if you want to see this book, just go to this site, and it's free. You can download a PDF of it, and it's got some really good stuff. So Peter and I became friends, and we actually had a conversation, and which led him to this book. So I just have these 4 quotes from Peter that relate to what he and others were thinking in Malmo, and then what he and I found to be a very common thread between how we both looked at the urban environment. Him from a civil engineer perspective, who was with the city of Malmo as a wastewater engineer, something like that, and myself as a landscape architect with another wastewater utility. So anyway, the intention of the book is to describe Malmo's transition from traditional drainage and buried pipes towards a sustainable urban drainage in open systems. So when he heard me talking about the landscape and his idea of having open systems, it was very, very much in line with each other. Anyway, then he talks in the book, he gives a lot of experiences. When you enter the path of sustainable urban drainage, it will become obvious that the institutional barriers, and I'm sure you've run into institutional barriers. Anyway, so without reading all of these, but the one I thought was really interesting is he talks about that these things have to be integrated with the urban environment or the city, and that people that are in the city, the managers and staff, need to have the courage to withstand the traditionalists, as he refers to them. And you can define that how you might, because I'm sure you've all run into traditionalists who put barriers up to your designs. So I saw this at one of the projects. So Peter had white hair. I used to have dark, full hair, but so we didn't know each other's children. It just, I saw this at a swale. But we used to have these talks, and one of the things we talked about, in thinking about this more philosophically, we have these characteristics, and as Joan was talking about, that how we look at things, but what is the philosophical basis that has brought us to view things with the perspectives that we have? And how might other philosophies or cultures, maybe another word is cultures, view things differently? And so we're in this big world now where I think that's an important thing. So Peter and I used to talk about it, and we really didn't have an answer. So the main points I wanted to, as it relates to saving money, is this idea that if you put the water in the landscape or actually create landscapes to capture the rain and everything else we've been talking about, that's one of the methods of saving money on development. And manage water on the surface in vegetated systems. And if you want to know which approach is most cost effective, first design it in a traditional way, and then redesign it green, or design it green and then design it conventional. Now, who has money or time to do that? Or who has a client that wants you to do that, right? So it's only been by accident that we came across some of this information, and then I've sort of looked at it as the years have gone by to actually take projects. And I have some more in here. This is my main point, but I want to get now and just show you some other ones. I was going to tell you a story about my garage eco-roof and the yellow tulip, but I'm not going to tell you that. You've all seen this in all our cities around the world. I thought somebody probably wouldn't have a photograph of a stormwater discharge. These are 2 discharges from our downtown area that we can not be very proud of. These are 2 different storm events. We have 150 roughly a year. This is our big pipe, and this is what Philadelphia is going to try and minimize in their work, and they're going to go green, as Steve and others have mentioned. And so this is what we've got, though. And unfortunately, we didn't think green enough fast enough before we spent $1.4 billion. So ours are done. And this one I thought was interesting because wasn't it funny that this truck happened to be at this location when the pipes had already been malfunctioning for years, but when the street finally caved in. This is in Portland, and this kind of stuff happens. So the people that talk about the gray and the conventional approach and how inexpensive it is, when it blows, it usually is a catastrophe and it's really expensive. But maybe it doesn't happen that often. This is another project in Portland. This is a conversion of what was going to be a rose garden right here into a rain garden. And this is another Marassi project. And this one, the developer brought me in. I forgot what happened, but somebody said, call Liptan at the city and he'll give you some ideas. And so we talked about this, and I said, well, why don't you put the stormwater into these two areas? And they said, well, we can't. It's a raised, rose garden planter. And I said, well, why don't you just depress it and don't put roses in it, put other plants in it. So they went for it. Marassi went for it. But the engineer on the project did not want to do this, and he told the client that it should not be done. So we were in a meeting, myself, his other consultant, and the developer, and the consultant said, well, I don't want you to do this, and I don't want to do it. So the developer said, well, okay, I guess I'll hire somebody else. So that was the end of the meeting, and about a week later I heard that it was being designed and that consultant was still on the job. So hopefully he learned, and I hope he's been doing more of these since then. But this was 1998. Anyway, so it's got the runoff, and then this is part of the required landscaping. That is the stormwater management facility for the parking lot. It drains into that area. And then just real quick, I know I ran out of time, but this is the Headwaters project. It was in a pipe, so somebody talked about a project in a pipe. Who was they? Yeah, Warren. And so it's a creek daylighting. And see this street right here? This is going to be important. So that little thing, and then here's this traffic island. So have you ever thought about how our cities are designed, and how many streets do we have that we don't need? Ever thought about that? Or if you're some new cities and you're designing cities. So what happens on this is that here's the new creek alignment. This is where the creek actually used to be. And you notice the road is not there? Oops, went too fast. So we put the creek where the road was. And how did we do that? And it's, I have to say, I'm sort of a guy that's always saying why. My mom used to say, Tom, stop, enough. Or why did we do that? Or what's that for? And so I asked the question because we needed room for this creek. And I thought, well, this stupid street's in the way. And then I was looking at it, I thought, oh, it's not even safe. It's uncomfortable, it's not safe. So of course, I'm a landscape architect, not a traffic engineer. So the transportation department said, well, we think you're right, Tom. But you guys at Environmental Services, you have to do an analysis to prove that it really is. So we hired a traffic engineering consultant, and they confirmed that, yes, this would be a much safer, better intersection for everybody involved if this little side street did not exist. And so we took it out. Well, and then, of course, our department had to pay for the daylighting and everything. The developer paid for daylighting this. And so you might think, well, why? Well, I'll show you a slide of what it looks like from above. So this is where the sidewalk is still there, but the street has been removed. That, to me, is like, we removed a street. We removed an unnecessary street, unnecessary impervious area. And that's kind of a thing. And there's a group in Portland called DPAVE, and their whole thing is to remove unnecessary impervious area. Anyway, so then this was converted to this. So the creek is actually over here. This is a rain garden that we used for retrofit. It's a retrofit for the upland commercial area, which is not in the photo. And then this is what it looks like where the creek goes through here. And then there's that kind of flume that goes through. And Kevin worked on this a little bit, and there were a group of us that, especially the rain garden kind of concept here. And then here, the street. So the creek goes through here. So you can imagine the original, when the developer was proposing this, the original design had landscaping in between the buildings, but the creek was in a pipe. It was proposed, it was in a pipe. He was going to be required to rebuild the pipe and put in a new pipe that was a little bit bigger and better and all that kind of stuff. And then the idea, and it was actually one of the planners that said, why don't you daylight the creek? And then we picked up on that and said, yes, why don't you daylight the creek? And he did. It was a lot of work, a lot of trouble, but he did it. And then this is Kevin's project from 2003. So this idea of retrofitting and getting the water off the system saves us money. And then the other thing about Portland, I think that's important that a lot of people haven't talked about today is we got into this idea, well, let's prove it. Does it work? So prove it. And so it was my bright idea to say, why don't we use a fire hydrant? We can simulate a 25-year storm with a fire hydrant. And Tim, our engineer, he calculates exactly what the 25-year storm is, and then we set it on the meter. We paid $15,000 for a meter. A little expensive, but we do a lot of testing with this. Anyway, so it worked. And then we have more. This is another one that Kevin worked on. Matter of fact, there's Kevin right there. So we did flood testing of this. It worked. It wasn't supposed to infiltrate. The infiltration rates were 0. We tested the infiltration rates. It was 0. That one goes at 1.5 inches per hour in the summer and about 1.25 inches in the winter. This is another one that we did. And all of these are retrofits to get water off the combined sewer system because we have to do it as a regulation, and the fact that they are our customers and we don't like sewage backing up into people's basements. It also helps with the combined sewer system. It reduces the flow that goes to the treatment plant and various other things. So it's a multi-objective approach. Besides, on this one, at the schools, matter of fact, all of these help reduce the urban heat island effect because we're putting in more vegetation, we're moving asphalt pavement. And at this particular school, I was here at night, and it was a really big storm, and I got there about 9 o'clock. One of the teachers was still in the classroom, and she had her window open. I thought, well, I better tell her that who I am so she doesn't get scared. And I went to the window, we had a nice talk, and she said, oh, I just love it because now my classroom is so cool. Most Portland schools do not have air conditioning. So in the summertime, when school starts and when school ends, it's warm. And she said, the first time in 17 years I've been able to open the window because you guys put the rain garden there. And it won an ASLA award. Yeah. Anyway, so then eco-roofs, we haven't had a lot of talk about what I call eco-roofs or intensive green roofs, things like that. But this is the Ford company. Did they do it for smart business? This is a company that owns a building that stores wine. So they wanted to really heavily insulate their building. This is actually for studying bugs. It's a bug tent. So we're looking at habitat on vegetated roofs. So this owner of this building wanted to max it out. This is one of our first demonstration projects. We stopped monitoring this. We monitored this for stormwater performance for 10 years. And then we've also monitored this. This is a retrofit on the Portland building. We did that for 6 years. And here's the results. So retention of the rain, and what the point of this is that it's pretty good for Hamilton. HAM means the Hamilton building, and PDX means the Portland building. And look at the difference in the retention, and the peak flow reduction is very close. But that retention, look at that, look at those percentages.
What was the difference?
Different substrate, different plants, different design with the insulation, stuff like that. The point of this is that they both work, but there is a difference. All eco-roofs are not equal. So it's something that we'll be working on. Well, I won't be doing it with the city. I'm having a little hard time. I've only left 4 months ago, 3.5 months ago. Anyway, and then in Portland, and this is happening with a lot of developers, the city passed its own policy that requires the city to put eco-roofs on all city-owned buildings. I'm hoping to work on requiring it on all new development buildings, whoever owns them, and because I just think it's time. I mean, they're affordable. I mean, the costs have come down dramatically in Portland from what they were, and it's just a good practice. The biggest thing that some of the developers who are doing this as their first choice is that it protects the membrane, thus they've extended the life of their membrane, and after 20 years they start bringing in money, and they're the developers that are hanging on to their properties, especially cities and things like that. And I think I've gone over time. This is amenity value and also money, profit for developers. This is Carol's project here, and this one is Marassi's project, and I think that's Steve's. Oh, Steve's over here, and so everybody's got a little piece in South Waterfront. Walker Macy's over here. But anyway, so the city gives floor area ratio bonuses. So you can do more development and make more money. And when I calculated how much extra development was achieved in the South Waterfront, it was equal to $240 million of the sale value of the condos before 2008. So of course 2008 hit, and everything went bananas. And this is a study we did on Icarus, and I won't go through that. It's just basically saying that after I could go through it. After 5 years, you get some of the money back, but you don't break even till about 20 years on the estimates that we used for Icarus at that time. The other thing about Icarus and all of this work we're talking about is jobs. And we really, jobs for cities, jobs for landscaping. So this is just looking at Icarus. So in Portland, we have 12,500 acres of roof in the city, plus it's likely that we're going to get twice that amount, or that amount again. And if you just use these numbers that I just was guesstimating about this, over $3 billion worth of work in the city of Portland on 15,000 acres. Not bad.
Just commercial flat roof or all roofs?
All roofs. Yeah, so that's why it's 15,000 of 25. Anyway, and then trees, trees and vegetation in the city. I think Kevin talked about it and some other folks talked about it. This idea of having vegetation within our cities, to me, is so important. And it's one of the things that we know the least about. How much do we need? So at the Urban Green Spaces Institute, which I'm going to be more involved in, probably at no pay, unless we get some grants. So we'll be looking for grants and donations, stuff like that. But anyway, so the idea is to take this question, how much green does a city need? How much vegetation does a city need to have a healthy city for its residents? And that, I'm sure, is going to be different for lots of different cities. And so we're only proposing to first look at our own city. How much green do we need in the city of Portland? And to meet what, right, there's lots of questions. To meet what end? Yeah. Anyway, and then one thing, this is for Stuart and Eliza. This quote, though creating something new, perhaps ARD, this conference, this idea is new, seems daunting and a big task. It's in fact easy when compared to the more challenging task to keep it going and to develop it further. And actually that's relative to all of us working on these issues, because it's so easy. And Kevin showed the newest rainwater garden that is only 2 blocks away from my house. It is the pits, and aesthetically, it's like, so anyway, so it's like, we're the big time Portland, but yet we're backsliding. It's not that attractive. It doesn't function that well. And how do we keep working to make it happen? And it takes nose to the grindstone. And that's all I have. So thank you very much.
Thank you, Tom. Okay, I know we're all exhausted, but questions? Joan.
I think you said that some of the rainwater gardens near the schools in Portland infiltrated far more effectively than you anticipated.
Mm-hmm.
And then you had a similar anecdote on one of the Marase sites, I think.
Mm-hmm.
So what do you think is going on in those sites in terms of the hydraulics, so that what you might model turns out to be different from what you actually see?
Well, this is still on, right? So we haven't been able to figure it, we being the Bureau, hasn't really been able to figure it out. So it's more conjecture, thinking about, well, how do plants and soil work? So soil, when it's disturbed, is no longer functioning as itself. And so in observing some of these, it seems after a period of time of maybe a few weeks to several months, maybe even 6 months, then it seems perhaps that the soil is sort of kind of like, okay, they're done messing with me and now I can settle down. The microorganisms and everything, and plants start growing. You get more of the bacteria and all the stuff that's in soil, that's alive and making the soil alive, that might be working. And then getting back to its characteristic as to how it really does work with regard to its infiltration characteristics of that soil. So when we did the test and the infiltration rate was 0, well, maybe it's because of the methods that we use for testing. And you've probably heard the 3-ring this or that or the other kind of testing methodology. And so maybe it's the way we test too. Now, it does seem that we've even tried this in some places where the soil is known to be a clay soil. And so they seem to work after a period of time too. For instance, Kevin and I worked on the new seasons, and I actually fell in the thing up to my knee because it was clay underneath, and they had filled it with topsoil. You know, they gouged it out. And so it was full of water, and it wasn't draining out because there wasn't a perf pipe. But if you go there now, it doesn't do that. The water does infiltrate to some extent, or infiltrate and exfiltrate from that trench. So I just think we need a lot more work on understanding that, because, you know, the bottom line, if you put a perf pipe underneath a facility, I mean, what's going to happen to it? It's likely to get plugged up with sediments and roots. I mean, you look at some of these drain mats that are under the vegetated roof systems. I pulled some up, and they're full of roots. And so if you think you're getting good drainage from that mat, it's after a period of years, it's going to be full of roots, and the drainage diminishes. So I think we're sort of, but you guys, I don't work in the east, so you use a lot of these under drains. So it seems to me like if you had a place where you could test, to me, comparative testing, comparative design, how do we normally do it, and how do we test things? And have you ever, any of you read a paper on how they test detention vaults or detention tanks or stormwater filters, you know, or something like that? There's not a lot of data out there that tells you how well a conventional gray approach to infrastructure design really works. And there's a lot of attention to this vegetated stuff. And guess who's pointing the finger at the vegetated stuff the most? The people that don't really get it that well. So it seems incumbent on the landscape architectural community to do its own research and get it documented, how well these things work. I mean, you can see some of the work that you guys have done. It's so beautiful, but how many of you have a chance to get back? You're consultants. You need to keep working. There's not money in it for research, and a lot of you don't really do research. And in the sense of looking at how the water is really working, and is it achieving what end, you know? So anyway, that's something I'm very interested in, that issue of how well this green infrastructure works. And I think the more we get of that, the more we'll be able to have conversations with design teams or others, and be able to say, this is how it works, and we'll just all be helping each other learn more about how water works in an integrated approach in the urban environment. Yeah.
So you mentioned retention of those green roofs and some percentages.
Yeah.
50 to 70 roughly. Were those percentages of the total annual rainfall, and does that mean that only 50% of that, for instance, leaves the roof, or is that percentages of certain storm sizes?
On that roof, both of those roofs, it's continuous 24/7, 365 monitoring. So it is representative of the, each year is representative of the rainfall for that year on those tests. So
So it is as simple as saying that whatever the balance is, that's only the amount that leaves that roof. The rest of it is retained, evaporate, or picked up.
it's kind of a neat way to manage stormwater by putting it back where it came from.
Well, I mean,
Evaporation, that's what it is. It's evapotranspiration is occurring, and it's going back up.
and
So
that
yes.
is in a fast draining 4-inch, or what kind of soils is that going through?
The Portland building is a 3-inch soil, and it was getting somewhere between around 60%. The other one is a 5-inch soil. It's a different composition. The soil mix is a different composition. So the other one is the one that gets 40 to 50%. So the 5-inch gets 40 to 50%. The 3-inch gets 60%. It's kind of like, hey, wait a minute, how's that?
I mean, those
How's
numbers,
that work?
I think, are amazing. And I've heard them before, but I've always been a little bit skeptical of them. But this is
Too bad we didn't
testing
have it
that
in
you've done.
1996
Yeah, yeah.
when you were looking for it. I did have an eco roof on my garage in 1996, but
Pardon?
I did have a vegetated roof on my garage in 1996, but I didn't have any data till the next year because so you missed it by a year.